Hello, everyone. So I'm going to go over line segments and distance notes that we went over today. So as we look at line segments and distance, we went over the definition of line segment. Line segment is any time you have a line, but it has endpoints and it doesn't go on forever. We call that a line segment. And the way we measure that is LM's line segment is 50. I told you betweenness is very important because it's the distance between endpoints. And then we talked about congruent being the same using this example here. The entire distance, 100, we have 50, we have 50. That's what congruent means. If you take things, they have to be equal. Could be shapes, could be sides, could be angles, could be anything. But we denote sides with these little tick marks, and that's a very, very common thing in reference for the rest of the year. It's going to be the way we delineate congruent. So then we went over some examples. So we have this one, 2 and 2.5 is all of our RT, so 4.5. And the same idea over here. We have a partial example here. We have the whole length of 6 and 2 3/4. We could just say that this is 3 1/4. Because 3 1/4 combined with 2 3/4 gives you 6. Over here, we have 3 1/2. We had to convert it a little bit. So we got 3 1/2 to 3 2/4 plus 3/4 equals 3 5/4, which can be converted to 4 1/4 inches. Over here is a congruency problem. Same idea, it's going to be 3 and 3. So this is going to be 3 centimeters. Moving on to the ones, now this is one of the unique ones. You have to actually draw the picture. And when you draw the picture, it pops out at you. Pops out exactly how to set up the equation. So let's do one over here. Same idea. We're going to do R, S, and T. RT is the whole thing for this one. It's 34. And ST is 3x and 12. So when you go to make your equation, it's going to be 12, which is RS, plus ST equals the whole thing, which is 34. Then you solve this equation in this way. It gives you 22, 2x. And here's where everyone gets stuck. So say you find the answer is 11. Did you read the question? The question says you've got to find the variable. Done. But did you find ST? You might have to plug that back in and find that ST equals 22. So that is how you solve that. We went over that in class. Now, distance we didn't spend as much time on, but it's a distance formula. So when you have the distance formula, it's the same as saying these two here, this coordinate A and B, I want the distance from here to here. You have to use the distance formula. Would it be easier? What if it was just this coordinate and this coordinate? Yeah, if it was a straight line, straight lines are super easy. If it's a straight line and you have to find the distance between a straight line, you can do that in a millisecond. You just say, oh, distance from here to here is 1, 2, 3, 4. 4 units. It's not that easy when you don't have it on a straight line. Even if it was a vertical line, you could do vertical lines easy. These are straight lines. In order to do a straight line, you have to use the distance formula. So d equals the square root of x2 minus x1 squared plus y squared minus y1 squared. And that is how we got the answer for 1, 2, and 2, 4 equaling square root of 5, which is 2.23. We also ventured into midpoint. When you get the midpoint formula, I told you always use the parentheses when you're doing midpoint formula. So same idea, you have two coordinates. I want the coordinate that's right in the middle of t, 3, 1, and u, 5, 3. And the coordinate in the middle is 4, 2. But you have to use the midpoint formula. So x1 plus x2 squared, x1 plus x2, not squared, sorry, divided by 2 gives you 4. And then y1 plus y2 is 1 plus 3. 4 divided by 2 is 4. So that is your section of notes for this unit.